Good afternoon. My name is Roger England. Today I'm presenting the second half of the two webinars on connecting witness to databases. The first session last week was concentrating on importing data, and we're concentrating on outputting data. My aim is to try and encourage more use of this particular area of functionality, which is we're receiving a lot more interest from customers on how to use databases of witness. We're getting more help desk cases, people requiring assistance. So I'm trying to improve on people's knowledge, also trying to debunk and try and dispel some of the fear that seems to surround databases and drives people to using Excel for absolutely everything. So as I said last week, bringing data into the database, bringing data into witness from a database was last week's session. This week we're looking at outputting results to a database. Should be approximately a 30-minute session. If anybody has any questions, then they can submit them via the WebEx chat. If anybody watching this is not sure how to do that, at the top of your screen you should see something like a green panel such as this, and if you click on the chat box, then a chat area will appear of this sort, and if you address your questions to the host, type something into the box and click send, then the questions can be seen by us. So I spoke last week about why use a database, but we'll go over that again. One of the key things about using databases is that databases are just for holding the data. Excuse me, I'm being told that people can't hear. Is that better? I think that's better. I'll turn the volume up a little. Yes. Part of the point of a database is that it's separated from the user interface managing the input of data and so on, and the business logic. This is more of an issue for the input side, and particularly when you're outputting results from witness. You really don't need all the extra stuff that Excel gives you that allows you to view that data. You really only need the reporting tools and so on. I'll come back to that again in a moment. Databases tend to be multi-user in comparison again to Excel, which is a single user system, so many people can use a database at the same time. You may think that that isn't particularly relevant for witness, where you're just updating the database on your local machine. But if you picture that you might actually be using witness several times, separate instances on your machine running on separate cores with the multi-core experimentation features that we have now, then you are actually in a multi-user situation. Databases are scalable. You don't need to pre-size things. You don't need to second guess how much data you're going to generate in order to do so. And unlimited at the other end, again, in comparison to Excel, which although it does have a considerable limit on the number of rows that can be held, it isn't unlimited, and we are finding in simulations recently that we need to have millions and millions of records in order. The other aspect of databases is that they tend to be built on robust storage hardware. The server software and so on tends to be very robust, and the applications that surround them tend to be written in an appropriate manner as opposed to more home-driven applications built around Excel. And there are, of course, a wealth of reporting tools, both online tools and some of the new Microsoft Power tools for providing dashboards and things of that sort that can be pointed at databases. Having bashed Excel somewhat, of course, databases and Excel are not mutually exclusive. It's quite possible to interface witness to. So yes, quite feasible to have Excel as an input for a witness model and use a database just for the output where larger amounts of storage size are required and so on. So the functions that we're going to look at today, DB open and DB close. DB open is required whether you're pulling in data or outputting data. We're also going to look at DB add for adding rows to record sets, and then the DB integer to field, real to field, and string to field will actually put the data into the database. And then we'll look at updating and batch updating, updating for individual records, batch updating for multiple records. And then also I have a case where we can demonstrate DB delete as well. So DB open then. Open, it must be stressed, is opening a record set. It's not simply opening a connection to a database. It's opening and getting a record set. There are several arguments to the DB open function. The first is a data source string. We discussed this last week. I'll go over it very quickly again today. A SQL statement must be required, and it must be a select statement. It must return a set of data. It can't be all sorts of other SQL statements for deleting or managing data. It must be a select statement. We also have a cursor, which we almost invariably set to 3, and a lock, which is set to 1. I won't go into any detail on those today. The other feature of using DB open is the handle variable, which is it represents the record set. So once you have the handle variable set, you can use that as a reference for other database functions. It's returned by the DB open when it succeeds. If you get a 1 back, then that was a success. If you get a 0, then that was a failure to open a record set. So an example in use that I'll show you in a moment. I've found that it's easier when using this to create 2 particular string variables. The first is for the connection provider data, the second for the SQL statement. Various reasons for this. It helps to tidy up the code and make it easy to separate the individual items of code. Also, it makes it easy when copying, cutting and pasting functionality from one model to another rather than copying whole DB open statements. Also, whilst the connection probably doesn't change, you may have a number of separate interactions with it requiring different SQL strings, and this makes this a little bit easier. So those would be built into a statement, something like this, having defined an integer variable called a VI handle, DB open, connection provider SQL string, and then the other 2 parameters there. In our example witness application that I'll show you in a second, I've created a very, very simple simulation that processes parts through a machine to generate a set of results which are held in a particular variable, in an array variable. And then in the first model, I've set up a user function to show how we would output the results at the end of the run into the database. We're using an access database today, so this would be the connection string for that. We define the driver for Microsoft Access, the name of the database file, and then in this case there's no security required. And the results table has 5 columns. I'll just show you those. So we have, those of you who are familiar with Access recognize this. Here's the table with 5 columns. I shall be outputting a group number, a part number, and a timeout. There's also an ID field, which is an automatically generated sequential number, which is pretty common in most databases. And then we have another field that records the date and time that the record was actually added to the database. I've also defined a couple of other queries, which I'll come back to in a second. One thing I should stress is that although I should be showing you the database today and showing you the data in the table, you don't actually need to install Microsoft Access in order to be able to output data to it, or indeed pull data back from it. So the demonstration models that we'll make available after this session, you will be able to install and use those even though you don't have Microsoft Access, which a number of our users don't. So I'll open up our witness example model here. So as I've said, I have a very simple, I have a part and I have a machine, and the part is pushing is being pushed into the model. If I open the model, you can see at the end of that I'm recording a part, so it's just counting the parts going through the machine and then entering the time entered model, so you can detect the time that the part was generated. I've got a random distribution pulling them in, so I've got the time, and that's being output to a variable called VR timeout. And when it reaches a certain quantity of parts, then the model will stop. So the quantity of parts is in my initialize actions. I'm using a dialog to define that number, and then I'm sizing the variable appropriately. So if I just run that very quickly, I'm going to run that for 1,000 parts, which are then stored in my variable here. So you can see this sort of random generation of data. I've then defined a user function, which you can see here, with a number of parameters. So the initial thing that I do is get the user to define a group number. I then have my provider string, my SQL string, and then I open the database in order to open the record set. That pulls in this case, select star from results means get all the fields and all the rows from the results table. If it fails to open, I've got a security check and a little confirmation that it's actually succeeded. And then cycling through from 0 to the number of parts that I defined in my in the original dialog. I'm adding rows to the record set. Then I'm inputting the fields, part, group number, timeout. They don't need to be in the same sequence as they are in the actual database that we're going to output. And then after each row, I'm outputting to the database. Right. Again, if it fails for some reason, then I get some feedback there, and then when it's finished, I get a confirmation. So if I run that user function, I'm going to put in a group which says A, and there, because I've set up print to give me that confirmation, you can see it's written on my 1,000 records. And sure enough, if I look in the database, refresh my table, there you can see 1,000 items. So I've actually got an existing set of data in there, and a query that I have set up here will actually detect the amount of the number of records that are already in there and how long it took to update them. I've got a query here to get rid of those results so that we don't so we can easily see the results from each run. So I've purged the results there, and we can start again. So that's a fairly simple demonstration of how you can output the results of your data to the database. Just a couple of words on structured query language, SQL. It isn't as hard as it seems. It's a big, expansive language, like many languages, but you don't have to understand everything about SQL to be able to use it with Witness. Indeed, SQL is only required in that data in the DB open statement to actually create a record set in memory for Witness. You don't need to use it to interact with the data after that. And actually, as I've already said, it has to be a select statement, so you are really restricted to what's required. And the sorts of things you'll see here are select star from my table, which means select all the records from my table and all the fields. Select part-time, I just want two particular fields from my table, and I've got a filter where something in the experiment field equals 2. And then later on I'll also demonstrate that we just want to count how many records are in that table. So as I say, most of the database functions in Witness are actually interacting with the record set after it's been imported. A little bit about record sets. Picture it as a table of data in memory. If you think of a spreadsheet, you have columns with different types of data in. Maybe some are text, maybe some are integer, some are real functions, real variables. it isn't a collection of data. It is a table. It's mixed. It's not an array type variable. You don't actually need to import the whole record set when you're outputting the results. All you really need are a list of the field names. So it is actually smarter to define a null record set with no rows. It saves actually going and getting any data from the database at all, and then you just add rows to that data set in memory. You can also, in the example I showed you, we were outputting part numbers one by one from as we were going through the variable. So going through our array one row at a time and outputting that, but we can actually build up a record set and output that as a batch. Depending on the connection that you have to your database, this can be more robust. So if you output row by row, that can be fairly slow. But if you build up a large amount of data in your memory and only output, say, every 1,000 rows, there's always a chance that you might miss a whole 1,000 rows output. Going back to the idea that we may have multiple users on the system, by outputting things in batches, you can actually interleave the data in the database between different models that you might have running on your PC, or indeed if you have different users that are outputting to the same database. By batching rather than streaming, you can allow everybody to get their data in at the same time, and I'll show you how we can do that. Also, batching can give you some flexibility on how you catch some of those errors. So let me go back to my model, and we'll go on to a slightly more sophisticated version. So in this case, same process. I'm outputting my parts and recording the information in this, recording the timeout in this variable. But this user function is a little different. In this case, we are, as I said, we are getting an empty record set. So I'm doing select star, give me all the fields, but only where ID equals 0. In actual fact, ID is never 0 in a database. So effectively, all I've got is a list of column headings, which is a quicker way of doing this. Then, rather than outputting each individual row, db add, integer to field, and then update, what I'm doing is cycling through from Y to VI quantity, and I'm actually building up a record set in memory, and then I'm doing a batch update of the whole record set. So that produces a different set of answers here, but it's possibly in some instances it may be more efficient. So let's just see how that works. So if I run my 1,000 parts here into memory, it's been stored in timeout, and then when I set my user actions and run there, I'll call this, so this is run number 2, 1,000 records succeeded. That's probably not actually much faster than the previous one. I'm not listing every individual output row there, but when we look here, sure enough, they're group 2, and there's the output. Those of you used to outputting through Excel read array, at this number of rows with a local database, then the performance is probably quite similar to Excel read array, or write array, I should say. So that's batching the information, but we don't need to actually file all the information in a variable before we output. It's quite possible, if I move on to this model, it's actually quite possible to stream the data out as we go. So every time a part leaves the machine, I can output the information at that point in time. So I can db add integer and then output after each individual part. What I do need to do, however, at the start is, whereas previously in my user actions, you may remember I was opening the database and then outputting either as a batch or as a stream from the variable. Now, in my initialize actions, I need to make sure that I actually open the connection at the start, and that I keep that open before I do anything else. So I'm defining the connection string, SQL string, and then doing openx at this point. So the result is pretty much the same. In this case, I'm not running the model and then running the user actions. The output will occur in a stream as the model is run. So in this case, I'll just run my model. It's 1,000. I'll call this is model number 3, so I'll call that group 3. Output that, so that has now automatically output that data into the database. Sure enough, if I go and look at the database, if I sort by descending inserted, you can see the data from group 3, and if I look at my little measurement tool here, you can see from that batch was output in less than a second. That's more or less instant in this case because I was streaming. It's taken 4,000 milliseconds, 4 seconds to output that data. So thinking about the idea of batching and making the most of that opportunity, if I now move on to my 4th example model, as I say, all of these will be made available to you after this session. So now, rather than output the data as a stream, I'm now outputting my results at the end. So the point of this is to demonstrate another way of not actually storing the data in our timeout variable. I'm actually outputting it from the machine into the record set directly. So in this case, at the end, I run a function called f export actions, and this will output all the data there. So if I run this model, see whether this makes much difference to the, this is model number 4. Again, run the model, and then at the end, that's output the data in a batch. If I refresh this, you can see actually it's made almost no difference to the performance one way or the other, but there may be practical considerations as to whether you want to stream the data or output it in a batch. Taking the idea of batching yet further, this model shows how we might batch things in a variable way. So in my model, in my initialize actions, I'm setting the quantity that we're going to use, but I'm asking for a batch size. So what batch size would I like? And in this case, I've got a default of 100. Sure enough, at the bottom, opening up an individual batch, and then as we go through, my export results is now run on a batch basis. So if I open up here, I'm setting my batch size, I'm counting through. If my record set size reaches the batch size, then I will fire off the export results, and at the end I fire that off to tidy up whatever's left. So unsurprisingly, if we run this, we'll get a batch size, and this is now module 5. So I'm outputting individual batches of 100, or if I take it back and run again, say 1,000, and I pick 333 for instance, and I'll call this 4A as my set. So this is outputting in batches of 333, and sure enough, and it's tidied up that last one. So if I look at my database here, you're seeing 4A, the larger the batch, the less time it's taking. Sorry, that should have been 5A, shouldn't it? Anyway, it's taking less time as we're batching things up. Just to illustrate the interleaving point that I made just now, if you picture that we actually have 2 models running. So if I wind this back and I start this, I'll output 1,000 in batches of 120, and I'll call that run. I'll call that run X. And over here I have another model which I'm going to run concurrently, and I'm batching that in a different batch size, or maybe the same batch size but on a different replication of a model, for instance. And then if I start that and start that, you can see the batch sets being output individually by the two of them. And if we look in the database, we would see in our results, as I refresh that and sort that downwards, you'll actually see results interleaved. You can see X and then Y, and you'll see the data interleaved there. Because these models actually run quite fast, it's quite hard to actually get them to interleave properly. But for certain applications, and clearly with multi-core, we could be running 4 or 5 at the same time. Just very quickly, I'll demonstrate one of the other ways that we've been working with Witness, which is actually outputting to Azure databases. So this is hosted by Microsoft on a server farm somewhere out in California, and there I have a table set up. This is set up for some more sophisticated experimentation. And if I look at my table at present, I have no data in there. If I go back to my witness model and open that, so in this particular case, we've now got a different connection. So we're connected to an Azure server with the database on there. Other than that, the only difference is that Microsoft Azure doesn't require an update in order to write the table. As soon as you add the records, they're added automatically. This makes adding the data much quicker. So I'm just doing db add, define all the fields, and then it moves on after that and closes at the end. So this model, I'll only run it for 100. Unsurprisingly, across the internet, this is a little bit slower. But if I give it some kind of a join there, and so sure enough, when I look in my data here, like that query, there's the results that I just generated from my model. That's been output to the internet. You could imagine you could have users across the world outputting to the same database, particularly when you start interleaving all the data. And this actually provides a very robust solution. I've left something running for about 12 hours and it didn't miss a single record at all. Going back to my show, I've discussed record sets and batching. One other thing we should mention is using db close after update. It does release the lock on the data table. It's good practice, to include db close whenever you finish with the set of data. A table is released or unlocked for other people to use after a certain amount in time by most data servers, and it is actually released when you shut down your witness model. But it is basically just good practice and tidy. As I've mentioned, Microsoft Azure doesn't require all of that. It just does it when you don't need to close it, because it effectively closes after each record. Just finally, I'll just mention a little bit about data checking. DB open is, or failures to connect, is the most common cause of problems with witness and databases. The bit that gets the most scary, and unfortunately, the causes of the connection errors are somewhat hidden from witness by the database connectivity functions of Microsoft Windows, but there is information that's available to help you understand what has gone wrong when the thing just seems to fall over for no reason. You've noticed in the models that we've been creating, I'll just fire up my final model. So in for instance, in our initialize actions, if it fails to open, create something that says print open failed, see witness log file, open succeeded, for instance. The witness log file can be found via the About Witness. I won't go into that right now. There is actually something on our blog which I wrote the other day to help you debug those. It could be that there's a problem with your SQL string, or it could be a problem with the provider string that's stopping you actually seeing that. But plenty more information for that available on our website. Integer to field. A few things to be aware of. There isn't any field name or field type checking when you try and connect. If you put in your SQL string, if you put in a field that doesn't exist, it may crash. But when you're doing integer to field, if you try and output to in my model, for instance, a field called port instead of a field called part, it won't tell you that there's a problem. It'll just carry on very slowly. It also won't check that you are outputting a string to an integer field. If you do, what you will get is a null. You'll get a blank instead of a number. If you output real to int, then it automatically rounds that to the int anyway. Other things, you can put checks on dbadd and dbupdate. It's good practice when you're interfacing to the models where in my function, for instance, in the actions, db check update, create variables such as check update and use that as a validation that your check update has worked and either record saved or failed to save, things of that sort. One other thing, just by the by, that you might try, for instance, is also to program in your own checks that data has been written correctly. If, for instance, you in this model, what did I do? Yes, this model, I've deliberately put something in the model so that whereas I've asked for an VI quantity equals 1,000, I've actually stopped the model if it stops short of that. So therefore, I can engineer a situation where I want 1,000 parts, my group ID is 6 or whatever. Just by the by, you can bodge this and actually see what the errors you might get in your log file. But I'll run that. So that's run, and you can see here it's actually output 998. And then I've created a user function there where it's going to open the database. It's going to count the number of records. So here we've got a where's my SQL string? Select count of ID as count records from there. So if I'm looking for, I've defined my group number at the start, so I count the number of records that were there, and then down here I can say if records found is not, if it equals the quantity that I asked for, so 1,000, then all records found. If it doesn't, it puts up a message, and then I put in something here to pull all the data from that particular group number back into memory, and then it actually goes around and deletes it. So when I run that, for instance, it's now removing all the data from that set. So if I look in my database, I should have run that beforehand. If I run that first, let's run it again just for the sake of it. So I'll run that, output that, and I'll put in a group of T, run that data, go back to my database. If I refresh that, I should see there's my record set T. So then when I run this, it says, oh, there's only 998 instead of 1,000. That's a bad run. I need to do it again. I need to delete that. And that happens very quickly, and sure enough, my set T has disappeared. So that's all I was going to talk about in this session. If anybody watching this now or on YouTube wants to hand me back any more feedback on other subjects to work with, then we can do so in the future. Just a list of some of the resources. Witness help obviously is available. The blog, I've been writing blog items for a little while now about databases, and will continue to do so as interest in this grows. MyLANA support portal, obviously there are solutions there if you're a maintained user. Our YouTube channel, which is available to everybody. You can email our support if you have questions, or if you've got suggestions for further sessions like this, you can email me. Also on the internet, there are all sorts of resources, SQL cheat sheets, etc., and horror stories about Excel, just in case I need to convince you not to use Excel for everything. Also, I must mention that we have our user conference coming up in just less than 2 weeks, so there's still time to join that. We have had a couple of questions in this session. This is from Rebecca. Does it work with databases that need to be updated online? Yes, it does. I think I've demonstrated that with Azure. If you want to talk about that some more, there is a blog item on connecting to Azure to do this, and we're doing quite a lot of testing. We're moving towards things like hosting witness models actually online, and that needs to be able to run with online databases. Yes, the data is effectively sent over the internet. So I understand that some people may have security issues with that, but there are ways of neutralizing that, or indeed just switching to other on-site databases that you may have. I think that's enough on that subject for now. Thank you for attending, or thank you for watching if you're on YouTube, and I look forward to hearing more from you in the future.